Hey guys, today we are starting sequences, and then we'll move on to series here in a couple of days. The sequence is any set of numbers or objects that can be put into a one-to-one correspondence with the positive integers 1, 2, 3, 4, 5, n minus 1, n. These are terms of the numbers used in a sequence. You can work through these. You can figure out the patterns. This one is 35, 1, 1/3. This one right here, if you add the two previous terms, you get 55. It's a famous sequence. It's Fibonacci's, which deals with the golden ratio, the golden rule, and all that. If you add the same number every time to get the next term, that's considered to be arithmetic. Or it might be better to say that it has a common difference, meaning if I subtract the previous term and I keep doing that, I should have a common difference as I move through the sequence. This one right here is infinite. The three dots there just tell you that continues, and this one is finite. This one is multiplying by 1/3 or dividing by 3 each time, so we consider that to be a geometric. Okay, so you can work through those. See if you can create a general formula for the fifth sequence above. Talking about this one right here. That should be a 4. So the formula is n squared. Because if I plug in a 1, I get 1. If I plug in a 2, I get 4. If I plug in a 3, I get 9, so on and so forth. So I take the term and I square it to get the first term there. Square 2, I get 4, so on. There's two different ways to write a formula. You have the explicit formula, where the formula gives the nth term as a function of n. That's an example of what we just did. And then you also have a recursive formula. Is a formula that gives the first term or the first few terms and then defines the nth term using the previous term or, that should be or, few previous terms. So we always let a sub n equal the nth term. So if you had a sub n minus 1, that's what they used for the previous term. Anytime you see that inside the formula, that's known as a recursive formula. The number of chairs in each row of an auditorium, follow this pattern. You just mark through that 1. 2, 5, 8, 11, so it's adding 3 each time. We're going to develop a formula. If you want the recursive formula, it's right down here. On the back side, they give you the formula. A sub n equals the first term plus d times n minus 1. Okay, so you may be thinking, what is d? Well, d is that common difference. If I take a term, take the second term and subtract the previous, I get 3. Do it again, I get 3. 11 minus 8 is 3. 14 minus 11 is 3. As long as that's common, as that's constant all the way through, then that proves that this is arithmetic. So if I'm going to create a formula, I can say that the nth term is equal to the first term plus my d times n minus 1. You can leave it like that if you want to work that out all the way to slope-intercept form. Let's see, you would get 3n minus 1. So either one of those will work. Flip it over. we've got some examples of some arithmetic. This one's arithmetic. There your D is 3. This one is not arithmetic. This one is arithmetic where your D is negative 8. This one is arithmetic where your D is 0.6. We're going to write a formula for this one. You could say that the nth term is 10 plus your D n minus 1. So that's a good formula to use. If you're going to find the 102nd term, we could say the 102nd term equals 10 plus 3 times 102 minus 1, which would be 303 plus 10 is 313. Now go back up to that formula at the top. Another way, you'll see this in some textbooks, another way to write this formula is, instead of the first term, you can say a sub m plus d n minus m. Okay, so what that shows you is that the reason we subtract 1 here is because that's the first term. If this was the fifth term, then you would subtract 5. So this could be helpful in problems like this example 4, where I can take the 45th term equals the 32nd term plus D. We don't know what D is, but we can say 45 minus 32. You get D equals 3. So I can use either one of these. We can go back. We can say the 32nd term equals, we don't know what the first term is, but we know our D is 3. And then we can say 32 minus 1, n minus 1. So 31, so we get a 93. You subtract that and you get 10. So our first 3 terms would be 10, 13, 16. Okay? Next section is something maybe you've never seen before. N factorial is defined as n exclamation point. That's how we write factorial. N times n minus 1, and you keep doing that all the way down to 4, 3, 2, 1. And it's just multiplying the numbers. A random note, 0 factorial is always 1. So we're going to write out the first 5 terms for the nth term equals n factorial minus 1. So the first term, we would say 1 factorial minus 1. Well, 1 factorial is just 1, and we get 0. 2 factorial minus 1, so 2 factorial is 2 times 1 minus 1 equals 1. The third term would be 3 factorial minus 1, so 3 factorial is 3 times 2 times 1. You get 6 minus 1 is 5. The fourth term is 4 factorial minus 1, which is 4 times 3 times 2 times 1 minus 1. So we get 12. 24 minus 1 is 23. The fifth term is 5 factorial minus 1. So 5 times 4 times 3 times 2 is 120 minus 1 is 119. So the first 5 terms for this sequence are 0, 1, 5, 23, and 119. Whoa, sorry about that. Now write out the first 5 terms of the sequence. So for the first term, you can plug that in. You get 1 to the 3 halves, which remember 3 halves is a rational exponent. So that's the same as square root of 1 to the 3, which is obviously 1. The second term would be 1 over the square root of 2 cubed, which would be 1 over square root of 8, which would be 1 over 2 square root of 2, which would be square root of 2 over 4. So there's your first 2 terms, and you can continue doing that to get the first 5 terms. And you'll see a pattern in there as you're working through that. And then the last one, write an expression for the apparent nth term of the sequence. So hopefully you can see that the numerator stays 1. We can say the nth term is 1 over, and so the second term there, the denominator is 4. The third term, the denominator is 9, so you can see that that should just be n squared. Or you could take it a step further and just say n to the negative 2. So there you go. This down here should say 4a. Sorry about that. And that's just an introduction to sequences. Enjoy.